Yeah, it's some questions regarding SAC.
Generally, regarding the algorithm or regarding the RLlib implementation and maybe an issue or something?
Um, just regarding the algorithms, performance questions, and some very general questions, I guess. Well, I've been training our SACH. We've noticed that a lot of the controls are really noisy, and we were wondering like what could we do to reduce that noise, whether it be introducing, say, some sort of reward function component where it looks at the delta of the change in the controls, or is there something else we should tune in our agent?
Right. So your actions are super noisy. Is that what you're saying?
Hmm.
Does the algorithm learn? Let's start with that.
Yeah,
Does it learn to begin with?
yeah, like it converges eventually. Hey Sven, so my
Hey,
question is
Sebastian.
regarding an SAC agent yielding a bunch of noisy actions. And even
Mhm.
while even after it converges to our optimal state, we are still seeing very noisy actions. So we're wondering what would be the best way to tame that, whether it be through a set of reward functions or some sort of hyperparameter tuning.
But does it reach some optimal state and then it kind of collapses again, or it's just the entropy just keeps or stays very high for some weird reason? Like
Yeah,
how happy are you with the policy's performance in the end? Let's say, despite the noisy actions, which is a very valid problem that we should fix.
um, and
Is it
it's
learning
kind
at
of,
all, or is it just really
I mean, and the prior one we had a very simple environment and we settled on it.
Mhm.
Now that we're having to do a bit more complex tasks, by the way, the SAC is working with a dynamic simulator.
Yeah, okay.
So, we want to minimize that noise in the actions as much as possible. That way, the
Yeah,
doesn't get too screwed up.
right.
Um,
Okay.
so like, of course, like initially when you start training it, the entropy is gonna be super high, so it's gonna do that.
Yeah, that makes sense. Yeah.
Yeah.
Exploration
But
wise,
like
yeah. And then,
as it's
yeah.
as it's training, it doesn't seem to be I mean the performance stays good, but it's just again the actions are noisy.
Yeah, I
Um,
see. Okay.
yeah.
Let's see. Uh, d- um, what is your action space? Like, are the values around 0 or like -1, 1, or is it very extreme? Like,
So
is it?
yeah, we have for example, is a 4D action space. All actions go from -1 to 1.
Okay. Okay. And okay, so that should. And then your environment also accepts these -1 to 1. Doesn't have to be scaled or anything.
We actually have to rescale them.
Okay.
Yeah. Then we feed the rescaled values to the simulator.
Uh, and how does that happen? So maybe okay. So you basically you do that yourself, basically the scaling. Before you send it to the simulator, you do something in your environment that's what I'm trying to get at is maybe in your replay buffer you have these scaled actions, or did you make sure that that's not the case?
Hmm. Shouldn't
Like
be.
your so SAC has this squashed Gaussian distribution, right? It's a very specific thing about
Right.
SAC that you don't have with the other algorithms. So everything that comes out of your network or out of your policy, compute single action or compute action, is already squashed, which means it's nicely sampled, and then the distribution itself takes care of the making sure everything is between -1 and 1.
Hmm.
And then if you specify your environment's action space as already the scaled one, let's say -100 to 100, then our lib would take care of that, and it would allow you to basically not do anything. It would take the value that comes out of SAC, which is between -1 and 1, would automatically scale it, send it to the environment, and make sure that the algorithm itself still keeps working in this normalized small -1 to 1 action space. So you're saying that when I take your environment and I say environment.action space, like what would I get? Would I get -1 to 1, or would I get
Yeah,
the
you get
scaled one?
-1 to 1.
Okay, and then you
Yeah.
scale it inside the environment. Got it. Okay. Maybe that's fine. If you handle all the scaling inside the environment, that should be okay then. Yeah, so I'm just brainstorming here. So entropy in SAC, how does this? Is this something? Did you monitor your alpha parameter or your alpha loss? Does it?
Let me pull it. Sven, you wanted my alpha loss?
Yeah, correct. I wanted to check the what it does. Alpha loss, the alpha value itself, or the log alpha, whatever.
So starts at 0 and then it goes down to -8 and slowly climbs back up, but in a rather noisy way. It's kind of like an inverted, noisy Gaussian kind of.
Yeah. Okay. And the alpha value itself, not the alpha loss, but the alpha value itself.
Alpha value starts at 1 and goes down to 0 in a logarithmic curve.
Okay. Okay. That sounds good actually. Oh, what is your which alpha do you start with? Maybe you're starting with a 1.0.
Yeah, I'm using the default alpha for SAC.
Yeah, sure. That may be worth playing around with. That has some effect on the entropy. Maybe you want to start with a smaller value. You may want to play around with that, and you also may want to play around with the target entropy. Yeah, so the target entropy by default is the product or the negative product of your action space's shape, which you said it was 40. Is that correct?
It's 4D.
Oh, 4D.
Mm-hmm.
Four dimensional. Yeah. So then it's just 4 the target entropy. Okay. Or -4. Sorry, it's -4 is your target entropy. So maybe you want to set this to, let's see, maybe set this to even lower values. Try like -10 or -40 or some orders of magnitudes to figure out whether that helps you reduce action entropy. You know? So this it could simply be that. It could be that you just have too much entropy in the, enforced by your loss into the network.
Gotcha.
Yeah.
I'll mess around with that.
Yeah, one thing to try out, definitely. If this is like purely like a problem when you do inference or like evaluation, you can try to set explore equals false.
Mm-hmm.
So when you let's say you're done with training and you think it's okay, reward is okay, but yeah, my actions are super noisy. You should try just simply switching off when you do compute single action in your inference or in your. You should probably try to set explore equals false. You should generally always do that because during inference or during evaluation, most of the time it's better to not have sampling or like stochasticity switched on or like exploration switched on. So that could help there too. That's to stabilize things. It could also like be not working well, but you have to try this. I would recommend trying explore equals false first. So when you do, let me ping this. Or is this a problem that you already think it's a problem during training phase, or is it just during?
It's mostly a problem during training phase, like late into training. It's still rather noisy.
This will not. Yeah, got it. Okay. So then try the entropy settings first, the target entropy.
Sounds good. Thank you.
Sure.
Excuse me, I'm wondering what is the difference between compute action once the exploration is off and training the agent once the exploration is off?
Yeah, great question. So during training, we basically call the same method in our samplers. We call it direct. There's a policy method as well, which the policy sits inside the agent or inside the algorithm. But it's kind of the same thing. You basically tell the neural network to produce an output. And during training, you certainly want exploration to be on because you want to gather exploratory data, right? And you want to explore the state space and learn from it. So it almost never makes sense in your regular config, in your regular training config, to switch explore to false. But most of the time, when you're done with training or you're evaluating, maybe you set up evaluation workers and you override some of those configurations in your evaluation config. It makes sense to switch off exploration. Every algorithm has a different exploration strategy. Let me give you a simple example. DQN uses epsilon greedy, right? So every n time steps, you act randomly. You don't listen to your Q network. You pick a random action from the action space. You want to do that during training because you want to explore the state space. But during inference, you most certainly don't want to act randomly at any given point, right? You always want to listen to your Q network and pick the greedy action that has the largest Q value. Does that make sense?
Yeah, so technically the bot should perform similar if I use train with the exploration off after the bot is fully trained, let's say during the evaluation mode, or if I use this compute single action with exploration off.
Correct. Switch it to off. It will normally perform stronger because it doesn't have this randomness at all anymore, which it shouldn't. It should be already trained. It should be already smart enough to give you the right Q values to pick from, or the right logits to sample from, or like to also greedily pick from in case you have the expression switched off. So it should normally, you should normally see like another boost in your evaluation because you're switching off exploration and now you're really just focusing on the perfect solution, right? And you're not distracting yourself anymore with trying to sample exploratory stuff. Like you really don't want to do that in inference. It doesn't make sense because you're doing inference. Yeah. You don't use the data for anything else other than in your production system. I'm not saying there are probably some weird cases where the optimal policy is like stochastic, and you need like if you play like rock paper scissors, the optimal policy is a random one. So in this case, switching off exploration is probably really bad. But that's I feel like we have learned that this is more like a theoretical problem, and it's in practice and in real systems, it's almost always better to switch off exploration once you are in pure inference mode / evaluation mode.
Yeah, it's more related to this curriculum learning. So let's say for our case, we are training a continuous bot with continuous action space. Let's say it's like it has 3 actions, but later on that we kind of make the task more and more complex, the number of action space also increases. So I was thinking, is there any way that we can leverage this curriculum learning approach to leverage the pre-trained lower action space bot and then start from there, or any approach that we can leverage the simpler bot for the more complex approach?
That's a very nice question. That's a tough one. It's almost like saying I want to change my network architecture right after some time. I want to without throwing away everything I've trained so far. That kind of you're kind of like making your network a little bit larger, at least on the action head side.
Yeah, or any way else that I can. For example, let's say if I start with the larger action space, but it just learns to do the simple task, and then at the next step, after learning the simple task, it starts learning a more complex task.
What you could do is so there are 2 ways of doing this. The first one is you start with the largest network, with the large action space, but you mask all the actions that initially you don't need, because your action space, your real action space under the hood in your environment is actually smaller. So your environment would have to look at the action masking examples that we have in RLlib, where your environment would have to provide those actions that are valid. And then with some algorithms, you can actually this works with PPO, APPO, DQN. You can mask the action. I know I've never tried this, but you could of course instead of throwing the network away and training a completely new one that's a little bit larger on the action head side, you could keep all the initial layers, maybe up to either the last one or the last 2 ones, and say, okay, at least I have learned already the feature until the automatic feature learning until that layer that I'm going to keep, and then only the last action head layer or the last 2 layers you throw away and reinitialize, or like but it's
but you could also just like keep all the layers, and then from the, let's say, 3rd last layers, then like add another 2 after you instantiate from the checkpoint.
And what do you do with the let's say you have 2 actions, and so your last layer is like 4 outputs, right? 2 for the mean and 2 for the standard deviation. And now you increase the action space to like you just double it or something. Would you also you wouldn't keep the last layer, right? You would, because that's You would definitely throw away the last.
Keep it around for the actions that I've learned already, and then just
okay.
kind of add
yeah.
add another head, so to say.
Yeah. But in that head, you keep the weights that you've already cool. Yeah, that could also work. Yeah, that could also work.
So you mean just adding one single neuron to the latest layer?
Yeah, that's what he's saying, right, Artur?
Yeah, or maybe add like another layer to the second last layer, and then like another neuron on top, or something like that. I mean, there's tons of variations here. Yeah.
Yeah, this is pretty bleeding edge stuff, I think, even in research, like how to do this right. How to manage like changing architectures without losing the pre-training success that you already had.
Yeah.
This will require you to mess a little bit with the get state, set state methods in your algorithm. But you can probably hack that. You can maybe over like subclass, either your policy or your whole, probably I don't know, whatever algorithm you use, the policy for that, the policy class, and then make sure that get state and set state handle this properly. But it's quite of a hack. We don't have an example for that, definitely not.
Yeah, what gave me good idea about I need just to learn how to do this kind of architecture changing.
Yeah, and again, this is something that's, I don't know, I've never done this, and this is very rare. But yeah, it's definitely we've had this question before from even one of our customers that wanted to utilize because they put so much resources into training something, and then all of a sudden they wanted to increase the action space. So they have the same problem. Yeah, I'm not sure it has to do with curriculum. Curriculum is more like on the environment side.
You know, in these cases that, let's say, for example, for continuous action space, because what we noticed once we added one extra action to our bot, the things got very much complex, and all of a sudden the training was much slower and unstable. Do you think if it works? Yeah. Do you think if it works if we change to discrete action space while using the SAC? Is it possible with Ray to have multiple discrete variables?
Theoretically possible, of course, but it's I think ours doesn't work with multi-discrete. Ours requires like a single, similar to our VQN. We don't support multi-discrete action spaces. Yeah, sorry.
If no one's coming up with another question, I can answer the initial question from Xorgress, who has been waiting so patiently throughout this. Are you there? Can you like?
Yeah, I'm here.
Something? Ah, yeah. Awesome, perfect. So let me share the screen again, because right, you were the one who posted an issue in the document before, so I had some time to have a look at this. So you were doing some interaction with civilization, right?
Yep, that's correct.
Which is really awesome, by the way. Okay, cool. So I tried putting lots of your code together to just get a running example of what you're doing, and then ran into some issues there where I didn't have enough time to dig into there. So I just kind of switched the environment to do something that is super similar. So instead of civilization, I went for this Waterworld environment. And obviously, it is like civilization. You said is like adversarial, right? I don't know if you have you seen Waterworld before?
I haven't. Oh yeah, no, that's different one.
I mean, it's this one, right? Okay, so this is like semi-adversarial, but I think that it doesn't really matter for your question, right? The thing in the end is, I mean, to rephrase your problem. You're running this algorithm facing civilization, and then you have this multi-agent setting where all these agents report different metrics, and then in the end, RLlib gives you the sum of rewards, like the mean sum of the mean rewards, right? I mean, it's like. And you want the you want them separated, and then possibly you want to just I don't know, stop running the algorithm if just one of the policies hits a certain reward and stuff like that, right?
Yep.
So let's look at this code, right? We can get rid of this for now to start with the code, how it would look without the solution, basically. Go over it real quick. So we have like a PettingZoo environment here. Then the algorithm doesn't really matter. I used PPO here. And then obviously you will want to, since this is like a multi-agent setting, you will want to put something in the multi-agent configuration options here, which would be a list of policy mappings, a list of policy, like a dictionary of policy, and then a mapping function, so that you kind of know which agent should be using which policy. Right. So if you run this right now, I don't even know if it would run without the code I just deleted. But if you would run it now, it would report back like a reward, which is the sum of all the agent rewards that are reported. And what you actually want is to have them separated, right? So, for example, I mean, this stopping condition here doesn't really relate to your problem, but you would want more metrics reported, right? You would want like in the overview that Tune gives you. Let me run this real quick so that you can actually see what I'm talking about. So in the overview that Tune gives you on every iteration, you would want them separated. So you could, I mean, in the newest version of Ray, in case you're working with that, you could do this with the CLIReporter, which is a tune feature essentially, which kind of out of the metrics that your algorithm reports, selects certain metrics and then places them into this overview here that you see after each iteration. So, but the same thing will happen if you run the Waterworld example. So initially, there won't be much to report back because the algorithm is just stepping over of the environment, but there's just there's no single episode that has been like a complete episode that has been learned on. Right. Yeah, let this run a little bit. So like in the meanwhile, I can talk about these callbacks. So like for many problems that you're facing, this would be enough. You could just select those metrics from the metrics columns that you would find to be reported back by the algorithm itself on every iteration. So this is like this large list of stuff that you see every couple of seconds, probably, if you're running something. So in there you would see, let's see, this looks good. Okay, right. So we have this metrics column here that is called policy reward max and policy reward mean. And this is the one that we would actually want to report normally. But in the beginning, as I said, and as we just saw, it's not there. So if we would, let's say, want to stop on that metric or checkpoint at that metric, we wouldn't be able to. So I don't know if that's the case for civilization, but it's just like a pitfall that I'm mentioning here. So what you would have to do is you would have to add this callback here to just set them to not a number on like every time we're reporting these metrics. So this is like this MyCallbacks class is like it can hold many different callbacks, but on training results would be the one that you would want to choose here, and you would hand it to the algorithm config down here, right? Config.callbacks, MyCallbacks, and then the algorithm, in this case PPO, but any other algorithm would know that every time it reports back all those training results, it will add in these columns here. And these columns are the ones that we are referring to down here, right? So this is Pursuer 1. Right, this is custom metrics policy reward mean of pursuer1, and we want to put in there just the policy reward mean of pursuer1, which we find in later iterations of the algorithms, or we put in there none. So yeah, that's essentially it, right? So then if you do that, then as soon as Tune reports stuff to you, it reports these metrics to you, then you'll see these rewards separated there, and then also you'll be able to stop on them if you reach a desired reward.
Okay, yeah, that seems to answer my questions. I just have one more additional question. This is a bit unrelated. So I tried without the separated rewards, and I tried running it for a bit of while. Then I noticed that even if I set up my maximum steps to be about in 20 turns, so RayTune for some reason stopped the time steps before the time step that I have initialized. So they have stopped at turn 12 instead of turn 20 that I set. So was there any additional parameters I need to set up, like RayTune set up a default maximum time steps that they have, or something else?
Yeah, so in RLlib, we have kind of two different ways of counting time steps. I mean, this could be something that's happening here. So if you're looking at a multi-agent setting, then environment time steps might be different from agents time steps. And I think this might be what's happening here, right? The single agent case, obviously, that's the same, right? You have only one agent that's stepping through the environment one time step at a time, but then in some multi-agent settings, maybe for your environment as well, an agent might take a turn while other agents are not taking turns, for example. Yeah.
Okay, that makes sense. Okay, thank you.
How do you make it learn on episode, so to say, right? I guess that was the essence of the question. So I have a script running here, which might learn eventually. I'll show you this real quick. So I mean, this would be how we would run SAC learning on episodes.
Here you're using the default SAC config. I think for these discrete action spaces, you need a very specific. You need different settings than the default ones for SAC. For example, your target network update has to be a certain. I think it has to be. You should set tau to 1 so that you get a full harsh 1 or 0 update on the target network.
Okay.
Set it to 1.0, and then the frequency has to be not 1, but like something larger, like similar to very similar to how you would run DQN. I don't know what the exact value is, but we can. And I remember that this made a big difference for tuning card pools in particular.
So the default frequency is 0.
Yeah, exactly, or 1. I mean, it updates every time, but it updates only according to like a small tau, so it doesn't fully override the weights, just kind of like pushes them in the right direction. Let's see, SAC tuned examples. Yeah, set the train batch size to like 32, for example. That's what it says here in our tuned example, and then the target network update frequency also to 32.
And tau to 1.
And then I think you can increase the learning rates a little bit, but it may not be necessary just to.
How does this
just look at the tuned examples process here.
Yeah, I see. Yeah. Okay, yeah. Let's see if it does actually.
Let's open it.
These optimization parameters. I think we should keep these around.
Yeah, try them. Yeah, we can. It should. Maybe it also works with the default learning rates. Oh, it's called optimization config.
Excuse me, regarding this setting, I'm just wondering why the default is just random sampling, because probably in most of the cases, the reinforcement learning agent is working with some sort of sequence of actions. The time related, the time is actually important. I mean,
right, but you in every sample that you take from the buffer, individual sample, you have the observation, the reward, and the next observation. So there you have the TD mechanism were kind of like in place working. And if you want, you can set end step as well to some larger values. So you have the transition, including the sum of some end step rewards, and then the next observation is not the really next one, but like the one like end steps after that. But yeah, that's the basic mechanism of TD learning. The basic form is just you learn by single time steps or by single transitions.
I see. Okay.
Yeah.
Well, this turns out if it does any better. I mean, so what this will result is actually something very close to this, like running a training that is very close to like a hyperparameter optimized training that we have run previously, with the only thing being different that sampling would not be random time steps, but complete episodes. That should be the only difference here. So
sounds good. Yeah.
Yeah, SAC is weird. SAC kind of like works best if you almost don't do any sampling. Like if you sample really slowly and just put everything in the buffer, and you keep like updating. And in this setup with the buffer, you do sample an entire episode first, right, and then put that in the buffer. So you're basically sampling very fast here. You're being very sample inefficient right now with this setup, if I understand everything correctly. I wouldn't understand why it hurts the learning progress. It should still learn because you're not sure. It may just take longer. I don't know.
I mean,
excuse me. Another follow-up.
It may also have to be retuned. I don't know. There could be some.
Another follow-up question on this. So let's say, for example, we have some good episodes considered like offline learning. We have some good episodes, and I've seen on the Ray documentation that we can kind of mix during replay buffer. We can mix the offline data, good data that we have, with the data that the bot is, collecting during training. Could you also let me know like how I can? So I want to use kind of leverage that good data or good episode to kind of initialize the training of my bot based on that and learn.
I think it's referring to where you basically in the config where you say input equals and then you do like a dictionary.
Yeah, but he tries to mix, right? He wants to mix offline.
Exactly. So you let it somewhat sample in the environment, but some fraction also comes from a JSON file, for example. You can set this up. Yeah. And then your JSON
you
file
can set this up.
Yeah. This is possible, RLlib. And you can you can specify the ratios. You could say 50. I want 50% samples coming from my environment, or 30%, and 70% from a JSON, or from this JSON file, and 5% from the other JSON file. You can set this up with the input config settings. It's in the documentation as well, but that's not kind of the same as preloading your buffer with samples and then specifying. So basically, your JSON file is basically your buffer. It doesn't change over time, so maybe that's something that you would want, that you just want initially the buffer to look a certain way and then slowly purge these samples. That's not possible unless you have a custom buffer that you can preload with something. But this what we're talking about right now, this setting with the dictionary and with the ratios, is purely you have some JSON file, maybe some sampling going on, and you can mix this.
Do you have an example file for this?
Yeah, let me just take a look at the.
Yeah.
So it should be in the form of JSON or like CSV file also it can read.
No, it has to be a JSON file.
Could we start out having the agent learn from the JSON file, and then save the agent in a checkpoint, reload that checkpoint, but just have that buffer be completely filled by its the experience it generates during training?
Yeah, if you use checkpoints, you can let's say set up one particular SAC config, pointing it to some JSON file or letting it sample. Then you can checkpoint, and then you can bring up an SAC that's similarly configured but has maybe a different input setting, and continue training that way. Yes, you could. It's more like the complex way to do things, but that's yeah, how
would you modify the checkpoint by hand and then just run from the checkpoint?
No, I would just use the checkpoint to keep the weights that are currently, and of course all the other the what else is in the checkpoint? Yeah, just the weights and the time step counters maybe, right? But then because you're creating a new agent or a new algorithm from scratch, and then you load the checkpoint into that, you can basically pick a slightly different config. You have to be careful, of course. You cannot change the network architecture, then it will explode. But you can definitely change the input source for that new created algorithm. Then it will just continue doing with the learning with the new input. To load into the buffer, we didn't finish this, right, Artur? Like we don't have a buffer off the shelf that you can kind of say I want to preload it with something, or is that possible also?
No, like this preloading is not possible by configuration. You would be able to like modify the complete algorithm kind of and code it yourself. Yeah, but not by configuration.
I mean, you can get to the buffer, right? If you have the algorithm in your script as an object, you can access the replay buffer, right? It's a property. And
absolutely.
And then you can say I don't know, set state of the replay buffer and just push in your JSON, so your data basically.
Yeah, that would be possible.
Yeah. It's a little hacky. You would have to be familiar with how the buffer stores the data. I think we'd store it as it's just a dictionary of NumPy arrays, right?
Yeah,
or it's a dictionary of lists of NumPy arrays. Yeah, with the columns.
I mean, I mean, you can basically instantiate the algorithm and then, I don't know, run it for a couple of steps if you like, and then stop, and then access the buffer, and then manually basically call add batch for however many batches you want to add, and then continue running the algorithm. So that would be possible. Again, that's like a not like a real configuration, right? It's like a small hack. Yeah.
That's right. You can use the add method or add batch method and add sample batches. I just posted the link to the mixed input setting. This is an example on the command line using the RLlib client. But you can do the same thing in your configuration. You can say config object dot offline data. That's the method, and then you pass the input parameter in. And set this to some dictionary where the keys are basically passed to your files, your JSON file, for example, or you say sampler, and then you give the ratio of that particular input method.
Okay, good.
Yeah, take a look at the example. That's how you can set up mixed input pretty simply with just Ruby configuration.
Actually, something that I wanted to do today, together with Christy, was a presentation of like how basically to get up and running with a sort of developer style setup of RLlib, right? So that you can make changes to our code if you find a bug or something, or if you want to contribute a feature, and then make your first PR and like how that goes basically.
Yeah, I mean, you can also do it, like maybe it's okay to do it next time. I feel like we're at time and maybe people have to go somewhere else.
Yeah, absolutely.
Yeah. We can shift this agenda to like next meeting in like 2 weeks. Right, next week is the summit. Is anyone coming to the summit from you guys? Next week in San Francisco. We'll all be there, so you have the chance to say hello and anyway, yeah. Thanks so much.
Yeah, Simon's coming.
I'm coming. You're coming too, Artur, right?
Oh yeah, I'm absolutely coming, and Simon's coming, and we're actually he posted an issue for us to work on together today, but it's just very complex and not well suited to dive into it together with so many people. So we're actually meeting up in San Francisco to talk about this.
All right.
All right.
Thanks everyone.
Thanks, Sven.
See you later.
Guys,
thank you guys.